Could it be that our sun is in a binary orbit that affects the rise and fall of civilization? Many ancient cultures seemed to think so, and now some modern-day scientists agree. If true, there should be evidence of advanced civilizations older than the 5,000 or 6,000 years we find in most of today's textbooks. A partner star to our own sun? While the concept of a second sun challenges our present understanding of the solar system, it is hardly a new idea. Some of the earliest astronomical records refer to the existence of dual suns. In fact, Mithraic beliefs were based on this concept. As we look deeper into the universe and expand our knowledge of its motion, we've come to realize that single suns are more the exception than the rule. With so many binaries in the heavens, why wouldn't our sun have a partner? Then again, if it did, wouldn't we be able to see it by now, with our high-tech observatories or the Hubble Space Telescope? While there might not be a visible companion, it doesn't mean one's not there. Some stars can't be seen at all, such as black holes or old neutron stars, and others, like brown dwarfs, are barely detectable. Also, the long orbit period of 24,000 years would make the connection of our sun to a binary partner extremely difficult to detect. One sign we'd expect to see would be the changes in the sun's rate of movement. In a binary system, orbital speed is not constant, and theorists say it would cause changes in the precession rate. If the current rate of speed were constant, a complete binary cycle would take almost 26,000 years. The scientists have confirmed that the rate of precession is increasing. In a binary system, this would mean that two stars are moving closer together, and the cycle would take much less than 26,000 years. The cycle of a binary system might also be observed in the geological record. Mathematician Milutin Milankovitch noticed the Earth has had global warming and cooling cycles that roughly correlate to the length of the Great Year. Just as the binary model answers questions of the past, it could also be applied to solve scientific questions of the present. For example, at the edge of our solar system is a field of asteroids known as the Kuiper Belt. In 2001, a team of scientists from the University of Michigan made a startling discovery. The asteroids appear to end very abruptly. A sheer edge like this would be expected in a binary system. Also, a large number of long-cycle comets in our solar system come from a very small part of the sky. Although some astronomers like John Matisse and Daniel Whitmire think it may result from the gravitational pull of an unconfirmed 10th planet, our sun's binary could also have this effect. Another enigma. All celestial bodies have angular momentum, a force that corresponds to their mass and motion. Yet in our solar system, angular momentum is unevenly distributed. The sun has 99.9% of the total mass, but only 1% of the total angular momentum. If we acknowledge that our sun is curving through space in a 24,000-year binary orbit, we find the sun's angular momentum was there all the time, but primarily in its orbital motion, not just in its spin. Although the possibility of a binary star agrees with many observed facts, it does raise questions. The most common objection is, if we were in a binary system, we would know it by now. But we may be looking for something that is very far away and very hard to see. New discoveries in astronomy and archaeology are adding more and more to our understanding of the true depth of our own history. If we continue these pursuits, perhaps we will prove the link between binary motion, precession, and man's place in the Great Year. History reveals that ancient cultures around the globe were aware of a great cycle that connected the movements of the heavens and life on Earth. The Great Year tracked not only time, but perhaps we will find the very rise and fall of civilization itself.